Good day everyone, you're welcome to my YouTube channel at SMDexecutive Academy. In this video, what we'll be learning today is the addition of vector. First, before we get into the questions here that we will be solving for us to give us clear explanation on how we add vectors together, I will explain exactly what we mean by that word vector. What do we mean by that word vector? When you hear the word vector, we have the opposite of it, which you call the scalar. Someone say a particular quantity is vector in nature. What does this simply mean? Vector simply means any quantity that has both magnitude and direction. The word magnitude seems to look like a bigger word, right? But in a very simple language, we can say any quantity that has value. When we say magnitude, it simply means value. It simply means a numerical data. If that quantity has a numerical value, then we can say it is a vector quantity. Also, when it's having a direction. So, but when we say a particular quantity is scalar in nature, it means that that quantity only has a numerical value, but no direction. I'll give an instance here. I'll give instances rather. First, for vector quantity, when we say a quantity is vector, it means that that quantity has value and it has direction. For example, is when we give an example of velocity, we say velocity has it has value. When we say, okay, what is the speed a particular object has attained and in what direction? So if we put that question that way, it simply means we're talking about velocity. But when we say a scalar quantity, a better example of a scalar quantity is currency. So I'm giving this example for us to understand in realities. So when we say currency, for example, in Nigeria, we use the currency naira. So if you're holding the money now, and someone asks you, like, okay, what's the amount of money you are holding? So you can only say the amount of money you are holding is maybe probably 50 naira, 100 naira. So which tells us that the value of that money is 50 naira. But do we need direction to understand the value of that money we need? No, we do not need direction. So it simply means that that kind of value, that kind of quantity, that currency is scalar. So scalar quantity are quantities that we only need their value. We don't care about their direction, because even themselves cannot give us direction. So when we say a particular money, like the currency of a particular money we are holding is maybe the value is 20 naira, and do we have to find the direction for us to understand if the money is truly 20 naira or what direction? So we do not need that. So for vector quantity, we need both the numerical value, and also we need the direction. If the direction is not given, we won't really understand, or even if we understand the logic behind it, we will not get the exact knowledge we need about it. So today we'll be learning how we add vectors together. So when we say vectors are quantity that has both magnitude and direction, what are the examples of vector quantities we can give for us to understand, okay, this is a vector quantity? A very good example of vector quantity is force. We know that a force is a push or pull of an object. But if you are applying a force, let's reason together. If you're applying a force on an object without a particular direction, like you're just applying your force to that object and you're not giving it the right direction, you will only waste your energy. Because if you apply the force in the right direction, you will need a little amount of that force to carry out that work. But if you're applying the force in the wrong direction, you will apply more force, which will lead you to having a load of work, much work to do. So if you're applying in a very good direction, the right direction, you will need a little amount of force to overcome that particular weight of that object. So we're going to give examples of how we add vectors together. There are about 4 ways in which we can add vectors. The vectors were always being given. So the first way we use is, number one, we use the first method. What are the methods which you can use to add vectors together? One, we can use, or first, let's say, instead of saying method, we can say the ways at which vectors can be added together, depending on the kind of question you are given. First, number one, we say when vectors are in the same direction. The first one we'll talk about is vectors in the same direction. So if vectors are in the same direction, how do we add the vectors together? For example, let's assume that we have objects here like this. We have an object here. This is the object, which we are intending that this object is needed to move to the front. So what we need is that we need to apply a force in this direction. If a force is applied in this direction, F1, and another force is applied in this direction, F2. For example, let's say the weight of this object is 100 Newton. For us to move this object to the front in this direction, we need an amount of force that will overcome the weight of that object. Because if you apply a little amount of force to that object, the object will remain static until we apply an amount of force that has to go beyond that particular weight of that object. So the weight of the object is 100, and F1 here, which is the first force we're going to be applying, F2. So in assumption, we are assuming that, okay, these two forces, in their addition is greater than this. Because the two forces are in the same direction. Recall we said that vector quantities, we consider direction. So we always consider direction. In which direction is these two forces moving? These two forces are moving in the positive direction. Normally, remember when we draw graph, this part of the graph here is the positive y, the positive axis, and this part of the y is the negative axis. This part of this x-axis is the positive x, and this is the negative x. So as our forces are moving this way, we assume that in the positive direction. So as they are in the positive direction, for us to add the two forces together, our total force, when two forces are applied to an object, the total addition of the forces are called the resultant force. When you sum two or more forces together, the result is called resultant force. Our resultant vector or resultant force is equals to F1 plus F2. This is quite simple. 2. We can add vectors together when they are in opposite direction, right? The first, let's assume we have objects, just like we have the first object. We have, let's say the object, okay, let's just assume we don't know, we do not know the weight of the object. We are assuming that this object now, we do not know the weight. And let's just assume we do not know the weight. And we are to push this object, like a force is pushing the object to this part. And there is another force, another vector pushing the object to this part. So let's tag this F1 and let's tag this F2. This is the first force, this is the second force. Recall we said that we consider direction. It's very important in vector. We consider directions in vector. And force is an example of what? Vector quantity. This F1 is in this direction and this F2 is in the opposite direction to F1, which quite means that this F2 is needed to be going in a negative direction. So we can say that our resultant force is equals to what? F1, which is the positive F in this direction, plus F2 is going in opposite direction, which will now have to make it like this, minus F2. So that simply gives us that F1 plus times minus gives minus, then F2. We can understand now that if two forces are going in different direction, we subtract. Ordinarily, from the beginning, we added them. We're trying to add. But because of the negative sign here, it resulted to minus. Like we have to subtract the two. Now, this is in two forms. Opposite direction and same direction. Opposite and same direction. Now, if we're not given two forces inclined at an angle of 90 degrees, what do we do to find the resultant vector or resultant force? Now, we are going to go this way. Question 3. If you have an object like this, now a force is applied in the north direction. Then another force is applied in the east direction, giving us, you can see that the two forces are perpendicular to each other. So when two forces are perpendicular to each other, or when two forces are inclined at an angle of what? 90 degrees. How do we solve the resultant vector? Now, they are not inclined at angle 90 degrees. Recall this is just, we have to understand that this is 90 degrees here. Now, we're taking this to be F1 and we're taking this to be F2. So for us to get our resultant vector, It's a logical thing that we do understand. Like, okay, let's just say there's a box here, and someone is trying to drag the box up this way, and someone is also trying to drag the box in this eastern direction. Then which direction is that force going to move? So for us to get the direction which this box or this object is going to move now, we have to calculate the direction of the resultant force and also the magnitude. All these things we've been doing. For every answer we get here, the value we have gotten is the resultant of that. Is the resultant of that addition of the two vectors, or we can say is the magnitude of the resultant of that. Because in this case, now I can say that we have not calculated any, or we have not found any direction. So in these two parts here, what gives us the direction is a sign. Recall I said that because this force is going in this direction, it has to be negative. So that negative sign shows that it's moving back away from this F1. But in this one, how do we understand the direction? So the direction here has to be understood using the knowledge of bearing. The compass bearing, probably we can also use 3-digit bearing. Now, for us to get our resultant force here, all we need to do is to close this, meet them together, and tag this to be our resultant R. So logically looking at this thing now, we can understand that the only format or the only principle we can use here now is for us to get our resultant is the Pythagoras theorem. So we can say that our R squared, that resultant square, equals to F1 squared plus F2 squared. So resultant vector will be equals to the square root of the square of F1 plus the square of what? The square of F2. That is exactly what we have for vector addition when they are inclined at an angle of 90. Lastly, if the forces or the vectors are inclined at angle lower than 90 or greater than 90, that is the angle less than 90 or angle greater than 90, how do we solve this kind of question? When questions comes this way, we have questions on the board. So these questions will really help us to use the methods which we have used previously. Now, we also assist us in solving questions when two forces or two vectors are inclined at an angle that is less than 90 or greater than 90. But when an angle is greater than 90 or less than 90, what do? We use the rule of the Parallelogram's law of vector addition in solving questions like that. So there's a question on the board. So this question will treat the perpendicular forces to each other when two forces are perpendicular or they are at 90 degrees to each other. And also when two forces they are inclined at an angle that is less than 90, and also when they are inclined at an angle that is what? Greater than 90, that's 125 degrees. Now, this we help us in understanding the questions, or probably how to solve questions dealing with vector addition. But previously we have explained that when we have two vectors in the same direction, we add them together, direct addition. When we have vectors in opposite direction, we add them, but we understand that there is a force between the two that we go in opposite direction. Then eventually we will subtract. So the remaining two methods in which question could come is when the two forces or two vectors are inclined at an angle that is 90, that is perpendicular to each other, and also when the two vectors or two forces are inclined at an angle less than 90 or greater than 90. Now the question here on the board says that an object is acted upon by two forces of 5 Newton and 12 Newton. Calculate the resultant of the two forces if the forces act perpendicular to each other. Don't forget, we have already explained to us that this word resultant simply means the sum of all the forces, or the sum of all the vectors acting on a particular object. So when these two forces are inclined at an angle of 90, let's see what we do to that. Now, first we need to understand that, okay, the first force is perpendicular to the second one. Solution to that question. Then we assume this is 5 Newton, and we assume this is 12 Newton. So with that, this is our resultant because we are using Pythagoras theorem. They are inclined at angle 90 degree. Resultant. Then our resultant square will be equals to 5 square because we said f1 square plus f2 square. So assume this is our f1, 5 square plus 12 square. Then r square will be equals to 25 plus 144. Then r square will be equals to 179. Then with that, because we have found the square of 5, 25. We have found the square of 2 of 144. Sorry, that's 169. So with this now, I can take the square root of both sides. R will be equals to the square root of 169, which is R equals to 13 Newton. So the square root of 169 is 13. Now, what we have found here is just the magnitude. Recall we said that vector we need to have two things: magnitude and direction. So what have we found here? We have found the value of the resultant, which is what? The magnitude. Then how about the direction? So for us to calculate our direction, the direction of the resultant is the angle the resultant makes with the horizontal. So we are going to find theta here. So the angle the resultant makes with the horizontal happens to be the direction of the resultant. So for us to get this theta now, we can only use our SOHCAHTOA, which will really help us in that case. So we can say that since we have known 12 here, we have known 5, we can say opposite over adjacent, that's tan. So say tan theta is equals to opposite 5 over adjacent 12. So tan theta is equals to 5 over 12, and 5 over 12, that gives 5 over 12 gives us 0.4166. That's 0.4166. So with that, we can get theta equals to tan inverse of 0.4166. So we check that. That's tan inverse of 0.4166. That gives us 22.619. So our theta is equals to 22.619, approximately 22.6 degrees. So this is the direction of our resultant force. So with that, we can tag that to go this way. So just draw our cardinal point here. So this is our cardinal point. This is the north. That's the east. We know this is west and south. So if this place is approximately 23, if this is 23 degrees, then what will this place be? That will be 90 minus 23, right? So 90 minus 23, that gives us 67. So we can say our direction for this is north 67 degree west. This is just the two things we always cherish in vector quantity. This is exactly what we always find in vector quantity. We find the magnitude, and also we will do what? We'll find the direction. We consider magnitude and direction. But for scalar quantity, we only consider the magnitude, because scalar quantities do not have direction, but they only have magnitude. Right. So this is the solution to the first part of the question. Now we'll go to the second part of the question. When the two forces are what? They are inclined at an angle that is less than 90 degrees. All right. Now the two forces are inclined at an angle that is less than 90 degrees. Let's see what we do. The first force, 5 Newton. Let's assume our 5 Newton. Okay, our 12 Newton still goes that way. 12 Newton. This is 12 Newton. Then our 5 Newton is inclining at angle 40 degrees. So we can just assume this is 90, like this. Then let's say this is 40. 40 to, that's 40 degrees. This is our 5 Newton. 5 Newton. Now, for us to do this, we obey the parallelogram's law of vector addition. For us to obey that parallelogram's law of vector addition, what we do is that from the point of meeting of the two forces, we sketch out another force, another line, which is diagonal to them, like this. That's the first thing we do. Once we are done with that, we transfer this force we make it equal to another, we make it this force equals to the other side, the opposite side. Then we dash it out like this. So this 5 Newton also appears here as 5 Newton force, as 5 Newton. Then this 12 Newton, sorry, let me just sketch this wall. 5 Newton. This 12 Newton will also appear here as 12 Newton. So with this now, we can see that we have parallelogram. It's looking more like a parallelogram. So we sketch this side out of it. So what we have there will be something of this nature. This is 12. Then this 5 here will be drawn out 5. That's 5 Newton. And this is 12 Newton. And this is a resultant, this one. And that's just what we do. Now, this place was given to be 40 degrees, but we have cut it, but not equally. We cut it, but it's not equal. So, if this is 40, we don't know the angle here, which is the angle here also. Can tag that to be alpha. So, for us to get our resultant, we need the angle for the resultant here. And for us to get this angle here, since we have known that the angle here is 40 degrees, then the angle here will be what we were given here. We'll subtract it from 180, because when you have an angle like this, or when you have a shape like this, the sum of this angle and this angle should give you 180. So the angle here is 40, then the angle here will be 140 degrees. Because 180 minus 40 gives us 140. Haven't gotten that. For us to now get our resultant, we use, this is what we call parallelogram flow vector addition. Under the parallelogram flow vector addition, then we obey the cosine rule to get our resultant. Then our resultant, r square, using cosine rule equals to f1 square plus f2 square minus 2f1 f2 times cos resultant. So our angle for the resultant is 140. Then our resultant we are looking for is r. Then our r square will be equals to 5 square plus 12 square minus 2 times 5 times 12 times cos 140 degrees. Then r square equals to 25 plus 12 square 140 minus 2 times 5, that's 10, times 12, that's what? 120. Then times cos 120. So can just say our cos 120 is equals to, is that 120? Sorry, 140. Cos 140 is equals to minus 0.7660. Minus 0.7660. So r square will be equals to 25 plus 144. That gives 169 minus 120 times minus 0.17660. All right, let's do that. 1 minus 120 times minus 0.7660. That gives us 91.92. 91.92. Now 91.92. So as we have it like this now, minus times minus, it gives us plus. Then 120 times what we have here is what we have here now. So we have r square is equals to 169 plus 91.92. 169 plus, then that gives us 260.92. 260.92. Now, as we have as 260.92, we already know that the next thing we need to do is to take the square root of both sides so we can get our r. So we can say that our r is equals to 260, that's the square root of 260.92. So then our r will be equals to, what is the square root of that? Then that gives us the square root of that 16.15. 16.15. So that simply tells us that r is equals to 16.2 Newton. So our resultant force for this question of two forces, 5 and 12 Newtons, inclined at an angle of what? 40 degree, is 16.2 Newton. So we know already that in vector, we are always considering our result, our magnitude and direction. So this is just the magnitude we have calculated. So for us to get our direction, all we do is that we find the angle between the resultant and the horizontal, which is the alpha here. So once we do that, then just like the first question we solved, then we relate that to our cardinals, north and south. So that will happen to be north. Whatever you have gotten here, subtracted from 90, is that will give us north. That result east. Now we only have one question left, and the question is, when the two forces 5 Newton and 12 Newton are inclined at an angle of what? 125 degrees, greater than 90. Greater than 90. So what we do to this question is, we are going to spread this question to our viewers all over the world. So this question is going to our viewers all over the world. Only eligible set of students who are to solve these questions are students who are in the class range between SS1 and SS3. That's between SS1 to SS3. So we're giving this question out to our viewers there to solve. So any student who is able to get this question correctly, the resultant between the two forces, inclined an angle of what? 125 degree, will be entitled to a giveaway of 5,000 naira. So if you are solving your question, make sure you drop your answer in the comment section below. Thank you.